Good morning, good afternoon, good evening. My name is Salman Basit, and I'm a product manager at MongoDB with security and compliance focus.
And my name is Pia Kocher, and I'm an engineer on the MongoDB Atlas team.
Today, we are excited to talk about MongoDB Atlas security for the enterprise. So what is MongoDB Atlas? MongoDB Atlas is a fully managed MongoDB service on AWS, Azure, and Google Cloud. It allows you to deploy, operate, and scale MongoDB Atlas clusters with just a few clicks. Today, all enterprises are software companies in one form or another. Cloud is the medium through which the software is delivered, either internally within an enterprise or externally to enterprises' customers. As an enterprise, you want to focus on building software or your secret sauce that will give you an edge over your competitors. Obviously, secret sauce is an example, but it applies to any software that an enterprise may build to further its business. Examples include a healthcare application or a modern payments application, which will require an enterprise to store customer data. As an enterprise, you want to focus on building your application or secret sauce. You do not want to worry that the place in which you're building this secret sauce is secure, or that you have to do a ton of work to make it secure. And this is what MongoDB Atlas provides. We not only make it really easy for you to make your secret sauce, but to do so in a secure manner with as little work as possible that you may have to do. By taking care of your security needs, either through always-on secure defaults or super easy to configure controls, you can keep your focus on building your secret sauce and stop worrying about anyone stealing your secret sauce. So what are the enterprise development and security requirements to make and sell their secret sauce? Broadly, we categorize them into three categories: develop, defend, and detect, or the 3Ds. First, and the obvious one, enterprises must develop their secret sauce as quickly as possible in a secure manner. Then enterprises must ensure that they have appropriate level of gates or controls in place to make it super difficult for anyone that tries to steal the secret sauce. Finally, an enterprise wants to record activity to its secret sauce or database so that if there is a misconfiguration or if someone tries to steal it, an alert can be immediately generated in order to take an appropriate action. Let's talk about actors and personas associated with these requirements. On the left side, the chef persona characterizes the developers. Developers are responsible for rapidly building the applications based on gathered product requirements. If developers are focusing the majority of their time on securing their application, then they would not have enough time to build the enterprise's secret sauce. The next set of actors, characterized by the Chief Information Security Officer persona, are focused on a defense in-depth approach. They want to ensure that there are enough gates and checks in place to prevent someone from stealing the secret sauce. Finally, there are malicious actors, both inside the enterprise or outside, that may attempt to steal the secret sauce. In this talk, we will describe how you can use MongoDB Atlas to meet the enterprise security requirements. First, we will explain how MongoDB Atlas makes it super easy to develop an application with its sane security defaults. Then we will discuss how you can defend your application in depth with minimal or no configuration. Finally, we will elaborate how you can detect any malicious activity to your secret sauce, that is your data in MongoDB cluster on Atlas, through a combination of pre-existing controls that MongoDB Atlas provides, as well as simple configuration to enable sane defaults for database auditing. Next, I'm going to hand over to my co-presenter, Pia Kocher, who will describe how MongoDB Atlas makes it super easy for you to develop your secret sauce as quickly and securely as possible.
Thanks, Salman. So, as Salman mentioned, while you're in the kitchen developing your secret sauce, you want to know for sure that nobody's going to be able to break in at night and steal the progress that you've been making. This secret sauce recipe is going to be the key to your success as the new burger chef in town, so you need to know that it's going to be safe. However, you don't want to spend precious time thinking about making your kitchen secure, and it's not your area of expertise. These days, data is the secret sauce in the software industry, and it's of utmost importance that it's kept secure. Let's talk about how Atlas ensures that your data is secure so you can focus on development. The first area of security we're going to talk about is encryption. It's important to ensure that your data is encrypted at all times, both when it's in transit and when it's sitting in the database. That way, if anyone is able to get past your other security measures and get their hands on it, they won't be able to read it. Let's first talk about in-transit encryption. Atlas has TLS on by default, and it cannot be turned off. This means that you can rest assured that any data traveling to and from an Atlas database is encrypted while it's in transit. TLS both encrypts data as it's moving between two endpoints and verifies the identity of both endpoints. The encryption provides protection against eavesdropping attacks, in which a malicious actor tries to read data that's moving between two parties. The endpoint verification protects against man-in-the-middle attacks, in which an attacker pretends to be one of the endpoints of the communication. Suppose your adversary is somehow able to capture traffic between your application and Atlas and compromise a current TLS session through an application vulnerability. Since Atlas uses ciphers with forward secrecy, even if the attacker does somehow manage to compromise a current TLS session, they cannot compromise any old TLS sessions they may have managed to store. We also take precautions to make sure that even if one Atlas cluster is somehow compromised, other clusters will still be safe. We have separate X509 certificates used for in-transit encryption for each Atlas cluster. This means that if one cluster certificate is compromised, it cannot be used to compromise other clusters. So now that we've discussed keeping your data secure as it's moving across the wire, let's talk about encryption at rest. In Atlas, your data is always encrypted at the disk level for both Atlas clusters and backups. This is on by default and cannot be disabled, which ensures compliance with standards like HIPAA and PCI. Atlas also provides the option to bring your own keys to add encryption at the database level for sensitive workloads. This feature adds an additional layer of security on top of the default disk level encryption and makes use of the Wired Tiger encrypted storage engine feature. We support keys from AWS, Azure, and GCP's key management services, and it's easy to switch among the three. We also offer client-side field-level encryption. This means that the data is encrypted in the MongoDB shell or drivers before it's even sent across to the server. This allows you to protect individual fields with all key management, encryption, and decryption operations occurring exclusively outside the database server, making it a great choice for particularly sensitive data such as social security numbers or passwords. With the inbuilt disk-level encryption and the configurable database-level and field-level encryption features, Atlas provides a robust set of encryption services that can be configured to meet your specific needs. So now we've discussed how Atlas encrypts your data at all stages of its lifecycle. Let's move to discussing user authentication and authorization, which is very important to enable and monitor so that you know who's accessing your data. Authentication refers to the process of verifying the identity of someone connecting to the database, and authorization refers to the process of granting access to specific resources in the database based on a user's role. In order to access data in any Atlas cluster, both authentication and authorization are required. When defining users and roles, it's important to keep some best practices in mind. The first one I'll discuss is the principle of least privilege, which means that you assign each user the lowest amount of privilege they need to effectively do their job, so as to restrict the number of people that have elevated privileges. The second is that each user should have their own credentials. This is particularly important for forensics. If many people are using the same set of credentials, it becomes much harder to discover what went wrong in the case of a breach. Let's first talk about authentication, which entails verifying the identity of anyone who's connecting to your database. Atlas offers several forms of authentication, but MongoDB's default authentication method is scrim, in which each user is required to have a password. In Atlas, there is also an option to auto-generate a secure password when creating a scrim user. Atlas also supports X509 user authentication, which is a certificate-based authentication mechanism. If you choose to create an X509 user, Atlas will generate a certificate for that user, which we do not store in our server. When the user authenticates, they need to present that certificate to the database, and it will be used to verify their identity. Atlas also provides the option for users to generate their own X509 certificates for database users. Another form of authentication that we support is LDAP. If you have an existing LDAP server, you can integrate it with your Atlas project such that you can map directly from LDAP users to MongoDB database users. This allows you to manage users in one central place in your LDAP server, which is really helpful for enterprises managing large numbers of users. We've also recently added support for authenticating using AWS IAM. You can configure AWS ARNs as MongoDB database users and roles, which is another way we integrate really well with your existing systems. Our Atlas secret engine for Vault provides another powerful way to manage authentication-related secrets in one place. HashiCorp Vault is a system for controlling and storing access to secrets such as passwords, certificates, and encryption keys for all the services in an application. It allows compliance and security teams to set policy and gives developers a single unified way to work with the secrets for their cloud services and platforms. The Atlas Secrets Engine, which we've worked with HashiCorp to develop, makes it easy to manage and control access for Atlas clusters, Atlas cluster users, while reducing security risks and increasing developer productivity. So let's switch over to talking about authorization now. In MongoDB, we use role-based access control to determine access to resources in the database. Each user is assigned a role that has certain privileges on databases and collections, which defines the data they're able to access. You can see here that I've created two roles. One is for the sauce maker, and one is for the burger chef. The chef, who is assigned the sauce maker role, is able to read and edit the sauce recipe. Other employees are given the burger chef role, which only grants them read and write access to burger recipes. It's important that we restrict access to our most sensitive data, which in this case is the sauce recipe. This way, if a set of credentials is compromised, the likelihood they have access to the sauce recipe is low. This is what it looks like to set up the roles that I just mentioned and assign them to users in Atlas. Atlas has several inbuilt roles that can be assigned to users. But if you need more fine-grained permissions, we also support the creation of custom roles, which is what we're doing here. Lastly, Atlas also supports LDAP authorization. This is related to the LDAP authentication integration I mentioned earlier and allows you to map directly from any user groups you may have set up on your LDAP server to MongoDB roles in Atlas. This way, anytime you add a user to your LDAP group, they will automatically be assigned the role the group is mapped to. Similarly, when a user is removed, that role will be revoked. This feature further enables you to centralize all of your user management in one place on your LDAP server. Now, let's discuss how Atlas ensures network isolation for clusters and go through a couple of different forms of connectivity that you can configure in your clusters. To ensure network isolation, each node in Atlas dedicated clusters are deployed inside of a virtual network. This means that communication among the nodes in a dedicated cluster occurs over the private internet rather than the public internet. The cluster is not accessible until the user sets up network connectivity. By default, Atlas clusters are not accessible from anywhere, and to connect, an IP or CIDR block must be added to the whitelist. It is advisable to choose the smallest range possible and try to avoid whitelisting any unnecessary IP addresses to the extent that's possible. It is also possible to peer external AWS, GCP, or Azure virtual networks with Atlas clusters in the same provider. If your application server is deployed inside of a virtual network, peering that virtual network with your Atlas cluster ensures that all of the communications between the two happen over the private internet. We've also recently added support for the private endpoints on AWS using AWS Private Link feature. When you enable this feature, Atlas creates its own VPC and places clusters within a region behind a network load balancer in the Atlas VPC. Then you create resources that establish a one-way connection from your VPC to the network load balancer in the Atlas VPC using a private endpoint. Passing it back to Salman.
Thank you, Pia. As Pia described, we have made it very easy to develop your application securely. Now we will describe measures that you can take through simple configuration to create strong defenses around your secret sauce, as well as measures we take for defense in depth of your secret sauce. These measures should make it amply clear that you can devote your maximum time in developing your secret sauce and not spend the bulk of your time trying to secure your secret sauce from adversaries. In particular, we will describe 3 types of security controls for defense in depth. That is, separation of environments and geo-residency, setting up multi-factor authentication and identity federation, and automatic application of security patches. As part of good security practices and compliance requirements, it is important that production environment is fully separate from development and testing environments. We make it super easy to do so. In MongoDB Atlas, a project is a building block for creating dev, test, production environments, and for applying and enforcing security controls. You can create projects with the click of a button, reflecting your development, testing, and production environments. The features discussed in the Develop section, such as encryption, network isolation, authentication, and authorization, are at a project level and can be configured independently for each project. This allows you to achieve a full separation of your production environment from dev and staging environments and is a foundational building block for creating a secure and compliant application. The projects are grouped under organizations. So if, as an enterprise, you have independent business units, you can create organizations reflecting those business units. And each business unit can create Atlas projects for their dev, test, or production environment. If your application requires data to be solely hosted in a geographical region or a country, or if there are latency requirements your applications must meet to serve your users as close to where they are physically located, you can do all of that with the help of MongoDB Atlas. First, you can specify a cloud region in which you will create a MongoDB cluster. This will ensure that your application data always stays in that geo or region. Second, you can create a cross-region sharded cluster and store the data of your application users in a MongoDB cluster shard closest to those users in terms of physical proximity. Together, this feature helps you meet any geo-residency requirements with the click of a button. Next, let's discuss multi-factor authentication and identity federation, which are an enterprise must-have for using a cloud service. MongoDB Atlas allows you to configure a second factor of your choice. Further, as an owner of an Atlas organization, you can require all users to enable multi-factor authentication. The options for multi-factor authentication include SMS, voice call, a 2FA app, or a hardware key such as YubiKey. These options provide you with an important control to implement defense in depth in line with your enterprise policy. MongoDB Atlas customers can use the same single sign-on identity provider that their employees use across other platforms to authenticate into MongoDB Atlas. This feature reduces security risk by having employees use single sign-on to log in rather than separately maintained credentials. This is all handled through Security Assertion Markup Language, or SAML. MongoDB Atlas makes it easy and intuitive for admins to control what users have access to in their MongoDB Atlas organizations. So you may be wondering whether you are responsible for applying security patches to MongoDB clusters on Atlas. Let's talk about it. The good news is that you do not have to worry about security patches at all. We apply security patches to the underlying operating system on which your MongoDB cluster runs, as well as MongoDB server, software agents, and crypto libraries. These patches are applied in a rolling manner so that your application never sees any cluster downtime. If you may require, you can configure maintenance windows so that security patches are only applied during those windows. Now that you have used MongoDB Atlas to meet your security requirements and rapidly develop your application, let's discuss how you can use MongoDB Atlas's always-on or simple-to-configure mechanisms to detect and alert on unsafe configurations or malicious attempts. Let's start with unsafe configurations. As described in the Develop section, an Atlas cluster is never accessible by default unless a user whitelists the IP address or a CEDAR range. This is in addition to always-on authentication and authorization for Atlas clusters, as well as always-on TLS from customer application to Atlas clusters. It is possible that a user may accidentally configure the cluster to be network accessible from anywhere by configuring 0.0.0.0/0 as IP whitelist. If such a configuration is accidentally made, MongoDB Atlas immediately sends an email to the project owner alerting the owner of this misconfiguration. As a CISO, you may be wondering what your employees are doing within MongoDB Atlas. We make it super easy for you to retrieve all activity your employees may have performed on Atlas. MongoDB Atlas provides a feature called Activity Feed, which records what users have done. You can hook this activity feed with your security information and event monitoring system, or a SIEM system, and alert on operations considered sensitive, such as creation or deletion of database users. Presently, this activity feed records all operations your employees perform inside Atlas, and the history is retained for the duration of your active account. So now that you're hosting your application data in MongoDB Atlas clusters, how do you track access and changes to data? Let's talk about it. MongoDB Atlas provides a one-click setting per Atlas project to turn on default audit settings. These are sane defaults that log any authentication failures to database, as well as track any major operational changes, such as adding or deleting a database or a collection. You can download these audit logs by calling MongoDB Atlas APIs, store them in your SIEM tools, and alert on any activity that you may consider suspicious. Together with other controls that Atlas provides, such as activity feed, network isolation, IP whitelisting, and always-on authentication and authorization, This should provide necessary defense-in-depth measures to track any changes to the data you store in Atlas clusters. Additionally, if you want to know what is going on with your cluster at a macro level, we provide you with easy-to-consume metrics such as CPU and memory utilization across cluster nodes. No configuration is required on your part. Let's do a recap. In this talk, we have described how MongoDB Atlas makes it super easy to develop and operate your application securely. By providing sane security defaults for encryption, authentication and authorization, network isolation, and by making it super easy for you to enforce enterprise security policies through separation of environments, identity federation, and alerting on unsafe configurations and unauthorized access, hopefully you can focus on developing your secret sauce and not spend the bulk of time worrying about how your application data is securely managed within MongoDB Atlas clusters. Lastly, it is important to point out that MongoDB Atlas is compliant to global information security standards such as ISO 27001, SOC 2, and PCI for cardholder data. Additionally, MongoDB Atlas conforms to EU-US Privacy Shield program and GDPR. MongoDB Atlas has also received HIPAA attestation by an independent auditor. To summarize, the security and compliance posture of MongoDB Atlas makes it super easy for you to manage your data in a secure and compliant manner with as little work for you as possible. Thank you very much for listening.